This problem has two parts because Franny does part of the trip at 60 miles per hour and part of the trip at 50 miles per hour. So we need to treat it as two separate problems to begin with, and then once we know the distance for each part, we can add those back together. So for each of these, we'll be using the same distance formula. Distance equals rate times time. And what we want to do with this formula is substitute in the things that we know. We're finding distance, so that will remain as our unknown. And in the first part of the trip, she's traveling at 60 miles per hour, and we're multiplying that by the time, which is 2 hours. I like to write it over 1 just so it's sort of organized and easy to read, but you don't have to. Now, when we say 60 miles per hour, we mean 60 miles per 1 hour. We never say that, but that's what we're trying to say. I notice that my units will cancel, which is exactly what I was hoping for, and I'm able now to just multiply. So multiply numerator times numerator, denominator times denominator, and this leaves us for the first part of the trip 120 miles. So now let's talk about the second part of the trip. We have the same formula. The distance formula does not change. Distance equals rate times time. What's different here is that the rate is 50 miles per hour. Still for 2 hours, but it's 50 miles. And again, when we say per hour, we mean per 1 hour. And we're multiplying that by the time, which is 2 hours, or 2 over 1. I notice the same thing happens here, that the units cancel, allowing me to, I'm left with miles as my unit, which is what I wanted, and I'm able to just multiply across now. So distance equals 50 times 2 is 100 miles. So I'm not done yet. To find the total amount of the trip, I need to add the two quantities. So I have 120 miles, that's from the first part of her trip, plus 100 miles from the second part of her trip, and this gives her a total of 220 miles for the length of the entire trip.